Hi everyone, thanks for coming to my channel, I very appreciate it. I'm Alex Gubin and this is the second part of creating ERC20 indexer on the Ethereum. In the previous video we broke down the basics of how to fetch events from the blockchain and prepare a foundation for our indexer. If you missed the first part, the link in the description. Today we move on and add TimescaleDB support for data manipulation, write migration with the Goose tool, and prepare a Docker environment for our indexer. Are you ready? Let's go. So for our indexer, we potentially need to store a lot of transaction data. That's why I want to use TimescaleDB, which is database exactly optimized for time series data built on PostgreSQL. One of the key concepts of TimescaleDB is time bucket. Simply put, it's how to break data into manageable time segments so you can make time-related queries fast and more efficiently. Let's look at one of the main features of TimescaleDB, which is called hypertables. The hypertable is a tabular structure which automatically splits data into time chunks using partitioning. This allows us to conveniently analyze a huge amount of data with fast queries. For example, using continuous aggregation feature, we can create summarized data view, which is automatically updated as the new data become available. Now, let's configure the Docker Compose file to run TimescaleDB in our environment. Docker Compose allows us to easily manage dependencies and connect TimescaleDB as a service. Essentially, the setup is the same as for PostgreSQL. Let's create Docker Compose file. So I have already prepared Docker Compose content, and here we can see TimescaleDB service that will be used TimescaleDB image with the 15th version. If you have already worked with Postgres, this configuration seems familiar to you, only the image will be different. Let's check our configuration by starting Docker Compose and waiting health status of our database. For this, let's execute Docker Compose up. Okay, we see database system is ready to accept connection. That means that our database was configured perfectly. Let's stop for now. Now we come to migrations. Migrations are the way of managing changes to the database schema. They help to keep the database up to date, especially when you develop and change your table structures. Or, for example, when you deploy a staging or testing version of your production database. For this purpose, we will use a tool called Goose, which simplifies migration process, allows you to roll back your changes and add new version of your database schema. So let's install it by using go install command. Okay, we have successfully downloaded this tool. Let's check. All right, let's add our migrations where data about our ERC20 token transfers will be stored. For this, I'm creating a DB folder with migrations. And in this folder, I run the next command. Okay, cool. Goose has created migration file, but let's change prefix of our migration file from timestamp to numeric increment as 1. It means that the next file will start with 2 and so on. Now we need to create a table of our ERC20 token transfers. I have just prepared some table. Let me explain what fields exactly meaning. Timestamp is the same as a block timestamp where event was emitted, and it's a crucial part of TimescaleDB hypertable. The next one is from and to. It's simple, it's Ethereum address. Amount, this is the real amount of token that were transferred. So what I mean, since ERC20 is a protocol, each such contract has a decimals field, which show the number of decimals places supported. You can easily go to token page on some scan and read the decimals field from the contract. And for USDC, it's 6. Little bit more explanation. For example, USDC supports 6 decimals, although actually in the real world, dollar has cents, which is 2 decimals as well. Anyway, it means that 1 USDC equals 1 million, and 2.5 USDC will be equal to 2.5 million. I think you get the point. This means that we can have floating number. That's why I want to use numeric type. The last two fields are transaction hash and token address. It's simple. The table is done. Now let's finally add the magic of TimescaleDB. We will use the create hypertable, which is a predefined function where we specify what field in our table is time. Remember, I talked about continuous aggregation, which is some kind of tool where we can aggregate our data in various ways, but TimescaleDB will update it for us automatically. So this sounds interesting, right? So let's see what is this exactly. Under the hood, it's actually a materialized view with using TimescaleDB continuous, and this is the place where we meet time bucket itself for the first time. I want the data to be aggregated by buckets for 5 minutes with the sum of all tokens during that time. Now let's add more magic and add refresh policy for our materialized view. Let TimescaleDB refresh our table every minute and enable real-time aggregation. This, of course, reduces query performance, but in our test needs, it will be enough. To check if everything is working, we need to start our database and roll up the migrations. Let's run Docker Compose. All right, and we need to roll up our migrations. For this, let's configure our Goose tool. We need to set a few variables for easier to use. So let's run Goose status command to verify that everything is okay. Cool, it means that we configure all perfectly. So let's roll up our migrations. There are some errors. Let's change our from fields to sender and to as recipient. Let's try again. Perfect. So we roll up our first migration and it successfully migrate to database and change migration version to 1. So with database is so our database is healthy as well. Let's move on. As you know, we need SQL queries to interact with our relation database, but I don't want to hard code raw queries. Therefore, in my work, I prefer to use such a utility as SQL-C. This is a tool that allows you to generate Go code based on your SQL queries. It's convenient because SQL-C avoids writing raw SQL in your code and it generates type-safe queries that are checked at compile time. This helps avoid potential errors and it eliminates SQL injection. Let's open the SQL-C documentation and install SQL-C tool. All right, we have already installed SQL-C tool. Let's add some configuration by SQL-C documentation. I just copy it from documentation and paste in our repository and change paths for our project. Nice, let's write our queries. DB. I will write our queries in DB folder. I have already prepared some query. This is a simple query where we save our ERC20 transfer. Now let's generate our Go code based on SQL queries by SQL-C command. And if there are some typos in my queries, SQL-C will tell us about it. Oops, column hash do not exist. So you can see I wrote just hash instead of tx hash. One more time. Perfect. Now we can easily use the generated SQL queries to work with our database. Now we have the database and migration set up. Let's create a repository for TimescaleDB. In the constructor, let's pass a database connection. And to handle Postgres connections, I prefer to use pgx package, and even more specially pgx pool. So let's import it. We can download it by go tidy. All right, let's use our generated queries with the import query package queries. So it's our generated package by SQL-C, and it won't exactly the same database connection. Let's implement an interface method and just call query save transfer. So it's look easy, right? And I just forgot one method we need to add. It's to receive our events for our HTTP handler. Let's add quickly. All right, and change repository in the handler. That everything works perfectly, we need to set up our DB string in our config. So let's edit DB, and in the main function we need to set up our database connection by pgx pool. Create our TimescaleDB wrapper repository and pass to indexer and handler. So now we can start our indexer with the TimescaleDB. Let's set up our DB environment variables. We use the same DB string as the goose, so let's override it. Okay, we start our indexer. Let's wait a few seconds or minutes. We see the first events. Let's check it in our database. I'm using Postico for view data in database and manage database. So let's update our ERC20 transfers table. Whoa! So it's very beautiful, right? We see that our configuration works perfectly. Let's see the materialized view that we create with TimescaleDB. So we see the only one row because it's actually one bucket, and we need to wait more time. In our case, it's 5 minutes. So in token address we see USDC token address, and total amount it's the sum of the tokens transfer by this time bucket. So let's wait and see the next bucket. Why is it convenient? Because TimescaleDB automatically refresh this materialized view for us, and you can see the total amount increase and the time bucket will adding, and this is convenient for analyze and for indexer some data, and for blockchain purpose it's very suitable using TimescaleDB. So as you can see, there are two time buckets for 5 minutes, and TimescaleDB will add more new time buckets by the time, so it works perfectly. So let's check our HTTP handler. We can retrieve data from our TimescaleDB, and our queries works perfectly. That's great. That's good result. That's a really good result. So let's wrap it up. That's all for today. This is how we are extending our ERC20 indexer by adding TimescaleDB support and managing database scheme by migrations. So in the next video we'll add some functionality for analyzing data and make the indexer more powerful. Thanks for watching to the end, I very appreciate it. Subscribe to the channel and let me know in the comments what else you'd like to see. See you in next episode. Thank you. Bye.